Good morning. Thank you for joining us for this moment. We want to take a moment to express my deepest gratitude to all the parents who have supported us. Today, we are willing to introduce this wonderful group of students who have worked tirelessly. So, Aimar, when you want.
Hello, we are Anartz, Olatz, and Aimar, and we will present our technology class project where we were supposed to create something which will form part of a smart town created by joining all the projects done in class. As a project, we decided to do a flat full of sensors and lights which were all designed owner to just not do anything in regard to the lights, chimney, and blind when it gets dark and dams.
Now you can see that our flat is decorated by simply painting, and almost the furniture is handmade from wood. We aimed that we have a cozy and a relaxing atmosphere, making this place as a warm and inviting place. Then what it comes to the electronic circuit, first of all, we have three different circuits. The first one is which connects the light sensor, which is named LDR. The second one is which connects the LDR sensor to the light sensors, to the light, and the third one is which connects the LDR order to the motor.
Regarding the blind, it is supposed to get down when it gets dark and go up when it downs. The lights for its part turn on as the blind goes down and turn off when it goes up. And to conclude, the chimney, which is basically formed by two colorful lights, it is supposed to light up when it downs as the blind goes up. As for the team members, we all contributed in our own way. I personally decorated the house, painting the walls, did the chimney and do the programmation for the circuit to work. Anartz assembled all the circuits, connected all the cables, did the couch and helped with the programmation. And Aimar helped to unite all the pieces we were creating while solving the issues we were finding during the process, and helped with the programmation also. And that was our project. Eh? The program of it basically sending an order to the LDR, which reads the light of the flat, and it makes the motor that moves the blind go up or down. This is by putting each one of the sarrera of the blind, one off and the other on. It depends on what do you want to do the blind, go up or go down. And the lights turn off when the lights passes a limit that we have put it. And after the chimney, it does basically the same, but but the contrary. Yeah, and that's the programmation of the program.
So as you can see in our project, when the LDR sensors get dark, all the light get on, and our blind start to move. Bueno, instantaneous problem that Do you have any questions? First of all, as the instantaneous problem, the Persian, the blind, it doesn't work very well, but until now he was working before the direct. According to all the project, I think that is an excellent project. That's okay.
Okay, a short break, and we're coming very soon.
Hello everybody, we are Naiara, Elordi, Gari, Guenaga, Aiza, Gandarias, students from 4DVH, and today we are going to present you our the smart house we did on our techno class. As you can see here, we have a house of 3 walls, a roof, and 3 floors with an open front view. And we decided to do a smart house because the initial project was doing a smart city, but we thought that maybe doing a house was a more original idea than doing a city. But it's true that we faced some problems when we wanted to add the circuits because we didn't have as much options as a city can have. But finally we could do a pneumatic circuit and and a LED circuit and a buzzer circuit. Naiara worked on the design of the house, Gari worked with the plywood, and I worked on the program of the circuits.
As Aiza said, we have 3 different circuits. The first circuit is the pneumatic circuit, the second circuit is the LED circuit, and the third circuit is the buzzer. The pneumatic circuit is done by a syringe without a string. Here you can see. It simulates a train toy. The second circuit is the LED circuit. This has wires, resistors, and are connected to Arduino by the breadboard. Here the breadboard, here the wires, and here is the switch. And the last system, the buzzer, is connected but wires to the Arduino system, and it plays the Simpsons song. The first idea was to play a Christmas song, but we couldn't do, so we put the Simpsons song.
For the design, we decided to do a Christmas-themed house because when we started the project, it was Christmas, and we thought that it could be a really great idea. We did a lot of details. We can see that upstairs we did a toy train. In the wall there is a Christmas tree. The materials that we used was most of it plywood that we used to do the structure of the house and most of the decoration and the details. We also used paint, paper, plastic, and a little of more, but that is most of it. And then the materials that we used to do the circuits.
Talking about the program, you can see that. Wait. Okay, you can see that the LED lights and the buzzer work together, and when the LED lights are on, the buzzer also turns on, and then it only plays once, the music only plays once, and the lights are on, and then when we switch it off, the lights switch off, and it works like that in a loop. So now we are gonna do a demonstration. Thank you. If you have any questions, ask, really. I think that's a personal question. And what I liked the most was doing the structure of the house and the design, because the program was very simple, so it was more entertaining designing the house.
My favorite part was doing the connections with the wires and resistors.
I also think that my favorite part was doing the structure and the details. Thank you very much.
Again, a short break, and we're coming with the third group. Thank you.
That's all. We are John, Julen, and Markel, and we are going to present the project that we have done. You can see that we painted a part of a town, and we have divided it into three sides. The parking lot. The parking lot has an automatic barrier that automatically opens and closes. The second part is the electronic part, and the third side is a river with some grass and a bridge. Then the road is divided in two lanes and two roads, and in the side of the road there are pedestrian paths. The wood one we have used is plywood, and we used a bandsaw to cut it. And in the beginning of the project, we drew a draft and we showed it to the teacher.
Here you can see the circuit which is connected to the computer which has a program. The wires are connected to the breadboard and the Arduino, and there are three different types of components that are three lights, one red, one green, and one yellow, a micro servo, and a buzzer. The lights work as a traffic light. The micro servo does the work of an automatic barrier of a parking lot, and the buzzer does a sound of a TV series called Looney Tunes with the light goes green, and in this way the people who has sight disabilities can know when he can cross.
We have done the Arduino program. The Arduino program is divided in three parts. Firstly, we organize the lights. We need to put the lights off and on each part. So it was a very long programming. Then each component, as I have said, it has its programming, and the buzzer. We have put the buzzer, the song of Looney Tunes, as I have said, and then we would like to improve our project with. We like to count how many cars they are going to be in the parking lot.
And now we are going to connect the wire to the computer. And the barrier now is closed because the traffic light is red. Do you have any questions?
Connecting the wires well, it was difficult. Any other questions?
Okay, see you in a moment. We're coming with the next group. Thank you.
Hello parents, we are Chia, Araitz and Yunan, and today we're gonna talk about our smart city. This time we're gonna make a quick review of what we did, the technical part, and our aspirations.
As you can see, we have made a small model of a city. On the one hand, you can see that it's divided into 4 parts, and here we have this beautiful beach that Yunan made, and on the other hand, we also made a red small house. Then we have a school that it's made with playwoods, and finally we have a football court with its trees surrounded.
Okay, so now let's discuss about the technical part. As you guys can see, we have made a fully functional traffic light with its classical shape and color pattern. The material that we have used to build it were more than 5 cables, 1 Arduino, more or less 4 resistors, and 3 LED. We used the green LED, yellow LED, and red LED. Then we had to program it to make it fully functional. So the program just makes some light to turn up in a specific pathway when this button is pressed, which is connected to pin 3, and then inside the program. Um, Inside the program, we divided into 3 main blocks. So in each block, we have 3 pins, and each pin corresponds to 1 LED. For instance, the 9 corresponds to green LED, the 8 corresponds to yellow LED, and the 7 corresponds to red LED. On the first block, we set the 9 on. This means that when we turn on the traffic light, the first one will be the green one, and the second block we set the 8 on. This means that the yellow one will turn on, and finally on the third block we set the 7 on. This means that the red one will turn on, and this process will keep repeating 900 times.
We have put a lot of effort and dedication to this project, from the beautiful beach and red house to the natural wooden school, and that has been all. Thank you.
Okay, so now let's show our traffic light. Do you guys have any question? So I personally believe that the circuit is the most difficult part, because when you have so many cables, it's kind of messy, and it's also very confusing.
Okay, we have 4 groups more, and we are going to do it very fast, as you can see. So see you soon.
Good morning, we are Eneko and Aratz, and today we are going to talk to you about your project.
The structure. We started with a wooden board, and that the idea is one rod board that is looked one made of Berriatua. First, we mark everything with a pencil. We show the teacher, and then we started painting. First, we paint the rod, and then of the egg of the rod. We put 3 houses on the corners, then a stop sign, and finally we put a street lamp in the middle of the road. So on the one hand we have the LED.
Circuit. We have the next components. Firstly, LED emits light when powered. A resistor 220 ohm between 1k ohm limits current to prevent LED damage. An Arduino board provides power and controls the LED. How do we connect the circuit? The LED had 2 parts. The another part of the LED connects to an Arduino digital pin. The cathode connects to GND through a resistor a limit current. How it works? The Arduino sends signals high or low to turn the LED on or off. High 5 volts, LED turn on. Low 0 volts, LED turns off. It is not very easy to mount this kind of circuit, although there are now a lot of components.
We can improve our project assembling more sensors. Basically, it would be great if we take into account some environment measures. It could be installing some photovoltaic panels. Thank you. You have some questions? I do.
What did each one do in the project?
I, I do the circuit, and now I do the structure. Yes.
Yes,
Thank you.
thank you.
Hi everyone, we are Aimar and Nicole, and today we are going to explain to you our Smart City project. This term, we built a pool with a bar where divas can meet each other. At first, we started building an ice skating rink because it was winter, but as the sun came out, we got inspired and we transformed it into a pool. We started with a plywood and we paint the grass, the road, and the pool. We also built the bar and we added some lights there. And around the pool, we make a fence with a rope. And finally, we added a door, the Olivas sign, and some details.
As Nicole said, we added the LED light in the roof of the bar so that it had a festive touch to it. And for this, we used a LED circuit. And to build this, we used wires, resistors, an Arduino board, a switch, and the LED lights. The current we used was 5 volts. And in the circuit, we programmed it with Arduino blocks. And then we added a light switch so that all the lights could work all together. For the program, this was our program. It's very simple. We had 3 pins for all 3 lights, and they all work together this way.
This was all. We hope you like it and have a nice weekend. Any questions?
Which one did you like more? The one from the previous evaluation or this one?
I think that this one, because it was more funnier to do all the decorations.
Thank you.
Thank you.
Yes, it's the same for me. Thank you.
Okay, 2 more groups and we're finishing. See you soon.
Oh, no.
Good morning, everybody. We are Neritz and Jare, students from 4th of DBH. For the third term in technology, we worked on a project called Smart City, which consists of a space with different circuits. For our project, we got inspired by New York Central Park, a place we truly love. In all the steps and all the process of the project, we have been working together and had an amazing time.
Okay, now I'm going to explain the design of our project. As Aneneris mentioned, for a project we decided to create a space inspired in Central Park. And we included 4 buildings with different colors. Also a crosswalk to the inhabitants. This way they can enter to the park safely. And finally, we create a natural park with an enormous lake surrounded by rocks. And also we have to highlight the material we use. That is plywood, paper, and paint.
For the circuits, we created 2 of them in order to make our project more creative. The first one we did was the LED circuit that, as you can see, resembles a traffic light. The wires you see here are connected to the Arduino that also has resistors that help preventing any possible damages. And then with the help of Arduino coding, we created the programs of them to make everything work. And now once we press the switch on, the lights turn on. And when we press it out, the lights turn off.
Okay, and now I'm going to, the second circuit we have is the screen circuit, and which represents a screen similar to the bright ones in Times Square. And as you can see, it says hello. And this was the second circuit we made, and is the same function as the LED circuit, and that's it, an Arduino.
Okay, so here you see, when we press it on, the lights turn on, and the hello is always there, and then the lights go out. Please.
And this is all. Thank you for your attention, and we also think that this project, we learn a lot with this project and improve our technology skills. Thank you. Yeah, any questions?
If you had more time, what would you add to the project?
Yes, no? We think that we had add cars, people, trees. Yes. More question. Yes. Question.
I think the part we like the most. Again, please, the question. The microphone.
What part of the project did you like the most?
I think that the part we like the most was painting all the park, and yes. Yes. Thank you.
Okay, the last group is coming. The last group is coming, so see you now. The last group is ready. So we have had a delay because we have had some problems. It's not working the project, just the LED, not the barrier. But well, anyway, they are going to explain it. So here we have.
Hello, we are Iker and Alex, and we would like to present our project. Structure and design. We started by planning the structure, the parking lot, houses, and roads. We carefully placed each element to create an organized layout. Building and drawing. After positioning everything, we drew all the components. Wiring and electronics. Finally, we worked on the wiring and electronics components. Arduino, the main controller of our system. The breadboard, used to connect components without soldering. Servo controls movements such as parking barrier. We have an ultrasonic sensor, and it detects movement or proximity to activate the servo automatically. It measures distance using sound wave. The sensor has two parts, a trigger and echo. The trigger sends a sound wave. The sound wave hits an object and bounces back. The echo receives the sound wave, and the sensor calculates the distance using time. When the ultrasonic sensor detects a car, the barrier opens. The red light switches off and car enter. We can improve our project by installing a counter. It will help track usage. The counter will provide accurate data. Thank you. Do you have any questions?
How much did this project cost, and how did you design the Iker panel? We already know it doesn't work like
Cost? The money? Ah. 5 classes, more or less. Short, very short, very much. Very much short. Yes. Paint the structure. Paint the structure.
Alex, and you?
The program. Yes. Thank you. Sir?
Okay, this is the last group. Thank you for being there at home, and see you in Los Arcos, the 28th of April. We're going to Los Arcos, and you will be able to follow our YouTube live streaming. Thank you. Bye bye.